Hi guys, welcome back to school. Hope you all had a really nice half term. If you would like to share anything that you did, I'd really love to hear about it. Leave a message in your book. Tell me how you are and how you got on, if you did anything interesting. I've just got a picture here of something that I did not in this half term but a while ago, and it just shows 5 different liquids that I've just poured on top of each other, and I just thought it'd be interesting. It's got absolutely nothing to do with the lesson that we're going to do today, but I just thought it'd be interesting to see if you guys could guess these 5 things that you can see in front of you, what they are. So have a guess, send me a message back, leave it in your book, and yeah, let's get to the lesson. So as ever, you're going to need your chemistry book, you're going to need your stationery equipment, and this should take you 1 hour at the most. If you have any questions, please email your class teacher, who is me, and I will be happy to help you. And remember, you need to write the information in the blue boxes, including the titles. And you have to take a picture of your work and submit it on class charts at the end of the lesson. I have been checking. I've been actually really impressed with the quality of your work, so thank you for that. And please don't get bored now. So I know it's really hard sometimes just to keep going, especially during lockdown when you're just staring at the screen all day, but you guys have been doing amazingly well. So keep it up, and if you have any questions, just give me a shout. Yep, again, some lovely examples of what you guys have been doing, so thank you. Okay, let's get started with a do now task. You have got 6 questions on here and 6 minutes to complete all 6 of those questions. If you get stuck, do remember you can skip the question and move on to the next one. You're also welcome to look at your notes as well for any answers that you just need reminding on. So 6 questions, 6 minutes. Have a go at as many of them as you can, and when you're done, let's go through the answers together. So press pause now and play when you're ready. Right, let's have a look at the answer to question number 1. Question 1 says, name 2 acids. So this is something we did from the last lesson. It's also something you might be familiar with from stuff you did in year 7 or just generally in science in year 8 and year 9 as well. So name 2 acids. An example that everyone, I think, remembers: hydrochloric acid, that's one. You could also have said nitric acid. I'm writing it like this so I can fit the answers in. And the last one, you could have said sulfuric acid. So sulfuric acid. So all the acids end in IC, IC, IC. Okay. So well done. You just needed 2 out of 3 of those. Any 2 would have been fine. Question number 2, all acids produce something in aqueous solutions. And we said in the last lesson, all acids produce H plus ions in aqueous solution. So if you remember, if I just draw a quick example at the top there, if I had a H plus Cl minus, this is hydrochloric acid. They are together. If I put it in water, the H plus ion and the Cl minus ion go their separate ways. So that's what it means that acids produce H plus ions in aqueous solution. You always get these H plus ions floating around the water, basically. Question number 3. The group 1 metals are called the alkali metals. Well done if you got that one correct. Question number 4. What is the pH of water? Water is neutral. This question was, I think, a little bit mean because we did pH in year 7. So what is the pH of water? Water is neutral. pH ranges from 1 to 14, and it is slap bang in the middle, neutral, number 7. pH of water is 7. Question number 5. What is the opposite of oxidation? So if you remember, oxidation is when we add oxygen to something, and the opposite of oxidation is reduction, when we take that oxygen away. Okay, well done. And then finally, when we see bubbles in a reaction, is a solid made or a gas? So when we see bubbles in a reaction, here are the bubbles. it is of course a gas that is made. So well done on all of those ones. Just take a few seconds if you need to make any corrections, and when you're ready you can go on to the next slide. So lesson objectives, I know I don't usually say the lesson objectives, but I'm just going to go through them today. We're going to recall the names of the acids. We've already done that in our do now task. We're going to recall that all acids are H plus donors. Again, we've done that in the do now task as well. We're just going to go through a couple of the diagrams to remind ourselves of what that means. And then what we're going to look at is we're going to look at alkalis, and we're going to learn that alkalis produce OH minus ions in solution. We're going to look at what that means. We're going to look at a couple of neutralisation reactions, and then we're going to go on from that. It sounds a lot more complicated than it is, and it sounds like there's a lot more than it is, but it's actually quite straightforward. So here's the slide that we did from last time. We're just going to have a quick recap on acids. You don't need to write anything down for this slide. I just want you to have a look at the names of the acids that you see in front of you, and I want you to have a look at the formulas, and I want you to tell me what you notice about either the name or the formula or both. So have a think about it. You don't need to write anything down. Have a look at what you see and what you notice. So we had an answer in our lesson last time, which I didn't even notice, if I'm being honest. We had all of these acids end in IC. And in terms of the formula, there was something in common as well in the formulas of all these acids, and that is that H that you can see right there. So all of the acids have got a H in their formula, and that's really because it's linked to the definition of acids. So what do acids do? Again, you don't need to write this down. This is just recap for you. So if you put some acid in water, it will produce a H plus ion. In scientific terms, we say that all acids produce H plus ions in aqueous solutions. Now, what on earth does that mean? Let's have a look at diagram. Here is hydrochloric acid. You've got the H plus in red, you've got the Cl minus in green. If I put them in water, they go their separate ways. Okay, so you've got that H plus is separate, the Cl minus is separate. There's your container of water. So put some acid in water, it will produce a H plus ion that travels on its own. That's what this scientific definition here means at the bottom. It just means that you've got a H plus ion floating around in the water. Okay, so acids produce H plus ions in aqueous solutions. Less acid, again, you don't need to write anything down. You've got nitric acid. There's the formula for nitric acid. If I put it in water, the H plus goes its separate ways. So we say this nitric acid produces H plus ions in aqueous solution. I've got sulfuric acid. This sulfuric acid in front of you produces H plus ions in aqueous solutions. Again, let's have a look at that diagram. You can see you've got a H plus here on its own, H plus here on its own. Okay, so this sulfuric acid also produces H plus ions in aqueous solution. And then let's recap the pH of acids. So if you remember from year 7, we said that universal indicator helps us determine the pH of a solution. So what you might have got is this little container that you can see here in the middle, and you would have had a beaker that would have had some acid in it, and you would have been asked to put some of that universal indicator into the acid. And if you notice from this picture, it's actually turned an orangey color. So the pH of this acid right here is 1. Just match up the colors. Okay, so anything between 0 and 6, pH between 0 and 6 suggests that it is acidic. Okay, so I'm just going to pop this on there. It should just take you 1 minute. I just want you to copy these sentences, write them in your book and fill in the blanks. You can press pause if you want to, or you can just listen to my amazing voice. Acids, all acids produce something ions in aqueous solutions. And for the second point, acids have a pH range between something and something. So for the first one, what did you guys put? All acids produce H plus ions in aqueous solutions. That's all you needed to put for that one. And acids have a pH range between 0 and 6. One thing I want you guys to be really careful of is to make sure that you write pH with a lowercase p and a capital H. So if I see this, then that's going to be wrong, and if I see this, that's also going to be marked as wrong. So pH has to be written like this. Okay, so all acids have a pH range between 0 and 6. Right, so we just had a recap on acids from the last lesson. What I'm going to do now is I'm going to ask you about alkalis. What do you notice about the following alkalis? Don't write anything down in your book. Just have a look at the names of the alkalis you can see in front of you. Tell me what you notice about the names, and tell me what you notice about the formula. Is there something in the formula that is the same in all four of them? And same with the names of them as well, of the alkalis. Is there something in the name that appears in all of them? So there are two things that you would have noticed here. Every single one has hydroxide in the name. Okay, so we can say hydroxide appears in the names of all of these alkalis, and it should. Okay. If we look at the formula, we know that all of these alkalis have OH in their formula. So I know I've got OH in their formula, and hydroxide is actually referring to that OH. So the name of that OH it's called hydroxide. Okay, so actually got a minus charge. So that OH minus ion is known as a hydroxide ion. That's the name of that ion. It's got a very specific name. So you're going to have to copy this page. I'd like for you to copy the diagrams on there. I know I said normally copy the things in blue, but because I've got some water in this diagram, I can't make the whole page blue. So if you just copy the information, copy the diagram, and I promise it'll make it easier for you when you look back on it to revise. So what are alkalis? Put some alkali in water. It will produce an OH minus ion. Okay, that's it. Okay, so in scientific terms, we say alkalis are formed when there are OH minus ions in aqueous solutions. So let's have a look at an example of this. There's sodium hydroxide. I've got the Na plus and I've got the OH minus. What happens when I put this in water? There's your water. You get an OH minus ion on its own in the water. Okay, so in order for something to be an alkali, you need to have an OH minus ion on its own floating around in the water. Okay, and that's what this means. So alkalis are formed when there are OH minus ions in aqueous solutions. So take 3 minutes to copy down the diagram in front of you. You can press pause and we'll go on to the next slide after that. Okay, so here's another example for you of another alkali. So what are alkalis? Again, put some alkali in water, it will produce an OH minus ion. Remember the name of this ion is called a hydroxide ion. It means the exact same thing. So lithium hydroxide forms OH minus ions in solution. So you've got lithium hydroxide diagram right there. If I put it in water, the OH minus ion goes its separate ways. Okay, so lithium hydroxide is an alkali. You don't have to copy this page down. Okay. if I use another one, a different example, if I put some alkali in water, it will produce an OH minus ion. So this one here is potassium hydroxide. Okay, so potassium hydroxide has the formula KOH. When I put that in water, you can see again that the OH minus ion has gone its separate ways. So potassium hydroxide forms OH minus ions in solution. This makes it an alkali. Okay, so anything that you put in water, if you end up with OH minus ions floating around in the water, then that makes it an alkali. Okay, so group 1 metals, if you remember from the do now task, we said that group 1 metals are known as the alkali metals. And all the examples that I've used in the last 3 slides, sodium hydroxide, lithium hydroxide, potassium hydroxide, all of them, sodium, lithium, potassium, are actually group 1 metals. And the reason why they're called group 1 metals is because when they react with water, they make alkalis. So if I give you an example here of lithium, if I put lithium in water, so lithium plus water, that makes lithium hydroxide plus hydrogen. So you'll see bubbles or fizzing because hydrogen's a gas. So you've got lithium hydroxide, lithium plus water makes lithium hydroxide and hydrogen. And you can see here, lithium hydroxide has a formula of LiOH. When I put that in water, the OH minus ion goes its separate ways. So lithium hydroxide is an alkali. All right, and all of the other group 1 metals are exactly the same. They all react with water and they make something hydroxide, something hydroxide, something hydroxide. So we're going to call them alkali metals because they make something hydroxide. Hydroxide makes it an alkali. And then if we look at the pH of alkalis, the pH of alkalis is on the other side of the scale. Okay, so you can see here on the left between 0 and 6, we said that's where we have the acids. On the right between 8 and 14, that's where we've got the alkali. So in this example in the picture that you can see, someone has taken some alkali and they've put some universal indicator into it. It's the one on the right here. And you can see that it's turned kind of a light purpley colour, so it's got a pH of 13. So anything between the numbers of 8 and 14 makes it an alkali. So if you put P indicator into an alkali, any number between 8 and 14 will make it an alkali. Okay, so have a go at these questions. Just take a couple of minutes. Very straightforward. We're just going to be filling in the blanks. Pause it and we'll go through the answers when you're ready. So we said that group 1 metals are called the alkali metals. We said that all alkalis produce OH minus ions in aqueous solutions. An OH minus ion is also sometimes called, not sometimes, all the time, called a hydroxide ion. And alkalis have a pH range between 8 and 14. So that's the information that you needed. Well done if you got those ones correct. If you need to make any amendments, just pause the video, make some corrections, and move on to the next slide when you're ready. Okay, so we said that all acids have H plus ions, all alkalis have OH minus ions, and they float around in the water. So when an acid and an alkali react, then they're going to make a salt and water. And I'm going to use a diagram here to show you exactly how it works. So I want you to copy this down for me. Okay, so acids and alkalis react in a neutralisation reaction. That's just the name given to any reaction where an acid and an alkali are going to react. And they make a salt and water. So I'll give you an example. Here I've got lithium hydroxide. So I'm going to write that in the box at the bottom. I'd like for you to copy the diagram, please, and then just label it underneath as well. So I've got lithium hydroxide. And if you remember, the OH minus ion makes this the alkali. And then that's going to react with, this is hydrochloric acid. How do I know that this is the acid? It's got the H plus ion, that's what makes it the acid. Okay, so this is the acid. And what's going to happen, really nice and easy way of remembering it, well, how I remember it anyway, is that the beginning bit of this and the end bit of this join up. So let's have a look at that. Beginning and end join up, and that is my salt. And you can see from what we've got lithium and we've got chlorine, but because it's reacted we call it chloride. So that's the name of the salt. Okay, and then we've still got two things left. There's the beginning bit of one and end of the other. So if we join those two together, bring them over on the other side, you can see you've got two hydrogens, one oxygen. That's actually water because you've got H2O. Okay. So anytime an acid and an alkali react, you always get a salt and you make water. And this is known as a neutralization reaction. So I'll give you a couple of minutes to copy this down. Please pause the video because there's no way I can speak for that many minutes without boring you to death. So pause the video, and when you're ready, I'll give you another example on the next page. Okay, so here's another example of a neutralization reaction. Don't worry, you don't need to copy this one down. I just want you to concentrate on it and have a look at what's made. Okay, so this time around I've got sodium hydroxide. So I've got sodium hydroxide. I'm just going to write it at the bottom for you. Sodium hydroxide, remember hydroxide makes this our alkali. And that's going to react with HCl. So this is my, oh my gosh, I can't even spell. This is my hydrochloric acid. And I know it's my acid because it's got the H plus. And those two are going to react together to make a salt. So remember we said the beginning of this reacts with the end bit of this to make our salt. And our salt is known as sodium chloride. So that's my salt. And what else is going to be made then? We've still got that blue OH minus and the red H plus. They're going to come together and they are going to make water. Okay, so acid plus alkali plus acid always makes salt and water. And here's another example for you. Again, you don't have to write it down. So this time we've got potassium hydroxide and hydrochloric acid. So we're going to take the beginning of this, end of this to make our salt. So those two are going to come together and that makes potassium chloride. And then we've got the beginning of this one and the end of this one, they come together and they make water. Okay. When they make water then, water is neutral and water has a pH of 7. So if we just recap all the numbers of our pHs, we said that acids have a pH between 0 and 6, alkalis have a pH between 8 and 14, and then slap bang in the middle where you've got something neutral, that's going to have a pH of 7. So this is your final task. I've got 3 questions here for you. I know the third question has got multiple parts. What I would like for you to do is try your best and answer all of the questions on here as best as you can. Pause the video please, and we'll go through the answers together afterwards. Okay, question number 1. Acids and alkalis react in neutralisation reactions to make a salt and water. Neutral substances, we said it was slap bang in the middle. Neutral substances have a pH of 7. And then we're going to fill in the blanks here for these reactions. So we've got lithium hydroxide plus hydrochloric acid makes lithium. Something's gone really wrong with my spellings. We're going to make lithium chloride plus water. For the next one, we've got sodium hydroxide plus hydrochloric acid. So we're just going to make sodium chloride plus water. And then finally, for the last one, we've got potassium hydroxide plus hydrochloric acid. We're going to make, follow the pattern, potassium chloride and water. Well done if you got all of those ones correct. Okay, that's it. That's the end of the lesson. Before you guys finish, I just want you to have a go at the quiz on here. The questions are very similar to what you've done. It's just to consolidate your understanding for this lesson. So the quiz is on Nearpod. Just click on nearpod.com, click on student lesson, and then enter the code that's in front of you, V3QIP. And I'll see you hopefully soon. Bye.